Good evening. I'm Spot On Weather meteorologist Matthew Euler, and tonight I'm doing a different video instead of the teleconnections. Since we're looking at a possible winter storm threat late this next week, I decided to change things up and switch gears a little bit for this Friday night on the video. And this picture here is a video in Hampton Roads area from a snowstorm that occurred back in January of 2018, just after the holiday season. By the way, this photo is courteous of Pilot Online. So, courtesy of the Pilot Online, thank you so much for this picture. But as you can see, it was one heck of a storm back in January of 2018. And in fact, March 12th of 2018 was the last time Hampton Roads recorded 1 inch of snow or greater on the ground. So it has been quite a while, folks. So what lays ahead? What's coming up next week? Let's go ahead and take a look at it. I'm going to start things off with the GFS forecast. Now this forecast is for Monday the 25th is on the left and Tuesday the 26th is on the right. And you'll notice we have a couple areas, a couple storms that are going to be moving across from Southern California across the basically to the East Coast over the next, between Monday the 25th and Friday the 29th. Now this storm is a lead storm. A lot of rain is going to be occurring with this lead storm. We're going to have a very cold weekend this weekend on the 23rd and 24th of January with highs in the lower to middle 40s. But then Monday we see a modification of the air mass. Now it's not going to be toasty warm at all, but it's going to be warm enough based on this storm track. There's an area of low pressure in southeastern Missouri there on the graphic on the left, and that track of the storm is going to basically go from southeastern Missouri through Ohio and into Pennsylvania. And with that kind of track, the thicknesses are going to rebound enough, the temperatures are going to rebound enough to where we see just rain across a good chunk of the mid-Atlantic. So you see the graphic on the left, the GFS model. We got rain coming down on Monday afternoon, the 25th of January. Looking at temperatures between 45 and 50 degrees. It's going to be a very chilly start on Monday with lows into the 30s, but those southerly winds will warm up the air mass and it will result in rain. Graphic on the right shows Tuesday and shows on Tuesday the 26th of January 2021 the storm system is moving off and away from southeast Virginia. Moving ahead now, the GFS forecast 27th to 28th of January 2021. So the 27th, Wednesday, is on the left, and the 28th, Thursday, is on the right. And a couple things I want to point out. Now, that graphic on the left, there's a 1041 millibar high-pressure system over eastern Canada. We have a couple pieces of energy. We have the graphic on the left showing some showers, basically from Georgia into Alabama along the Gulf Coast. And then we have a secondary piece of energy associated with the northern stream, and that's located over western Kansas. So we have two pieces. We have the subtropical moisture, and then to the northwest of that we have the cold upper trough. Now look at the graphic on the right. So we have a dry day on Wednesday the 27th, but then look at the graphic on the right. We have an area of low pressure which has formed just off the coast of South Carolina on the morning of the 28th, Thursday. And the pieces of energy have merged. We have a cold core upper trough there located over parts of western Virginia, and we have the piece of energy from the subtropical jet. And it looks like a merger here, okay? Notice there's rain moving into the Hampton Roads cities by Thursday morning, the 28th of January. Moving ahead now, for the storm itself, the potential winter storm. Graphic on the left shows GFS forecast with precipitation for Thursday afternoon, early afternoon, Thursday the 28th of January. And we've got a rapidly deepening area of low pressure or storm system situated off the Outer Banks at that time. Now, what does that mean for Hampton Roads cities? Right now, it looks like a cold rain for a good majority of the day on Thursday the 28th, based on this track, because this area of low pressure is so much closer to the coast. And that will then go ahead and drag in more of the marine air off the Atlantic Ocean. Now, I'll go over my breakdown here to end the video, but these are just model comparisons right now. This is the GFS. The graphic on the right, we move ahead now to Thursday evening, late Thursday evening on the 28th of January. And you notice the area of low pressure is deepening, it's intensifying, it's down to 986 millibars just to the southeast of the Outer Banks. And so again, we have heaviest snow inland away from the coast in this scenario. Looking ahead to the Canadian forecast, what does this show? Very similar synoptic setup. All these models are in very good agreement all the way out through about Monday the 25th and Tuesday the 26th, where we get this cold, high-pressure system in eastern Canada trying to filter some Arctic air southward. We got this energy, two separate storm systems, more southern routes. First one's a little bit further to the north, very similar to GFS here on the Canadian, where we got an area of low pressure basically forming in Missouri and moving northeastward to western Pennsylvania by Tuesday the 26th, with just some rain Monday evening and Tuesday morning for Hampton Road cities. The 27th and 28th of January 2021, this is Wednesday, Thursday next week. Now, look at the graphic on the left. See the blue snow shading? The blue shading indicates snow across Missouri, southern Iowa, eastern Kansas. And then we've got the rain along the Gulf Coast states, Louisiana, Mississippi, Alabama, and Georgia. Those are the two pieces of energy. The graphic on the left also shows a 1042 millibar high pressure system. On the front side of high pressure systems is where you get the coldest air because you have a clockwise circulation, a northerly wind component on the east side of these highs. Graphic on the right shows overnight, Wednesday the 27th, really early morning hours, just after midnight. On the morning of the 28th on the right, showing an area of low pressure. We have a phasing situation. We call it phasing, where the southern stream energy and the northern cold upper trough energy, they merge together and they form an intense storm system. All right, so GFS is showing that phasing, Canadian showing that phasing as well. And on the right there, you see early morning, just after midnight on Thursday morning, the 28th of January, we have a 1,009 millibar low pressure system off the coast of North Carolina. We have rain moving into Hampton Roads in northeast North Carolina, with snow a little bit further inland in places like Richmond, in places like Charlottesville, Fredericksburg, Winchester, and back into West Virginia. Moving ahead now to the 28th of January on the Canadian, look how wound up this storm system gets. And you notice how much further northeast the area of low pressure or the center of the storm moves with the Canadian model. It tends to be a little bit more poleward offshore. So southern New England can't be ruled out as a possibility for snow as well with this system. But you see things eventually changing over from rain to snow across the Hampton Roads cities according to the Canadian model. Now this is the midday model today on the 22nd of January. So I want to compare this again. Look at the track of the low pressure system. Okay. Now, let's go back to the GFS. Okay? Pretty similar, actually, but a little bit more seaward with the GFS. All right. Moving ahead to the European model. Okay, now, of course, I like to joke around and call the European model King Euro, because it does so well so many times with these type of situations, with storms, with the long wave pattern, where the coldest air sets up, the dynamics of the system. European is usually more superior than the Canadian and the GFS. So let's take a look at the midday run 12Z today, 22 January 2021. And you'll notice the graphic on the left is for Thursday morning, the 28th of January 2021. All right. And there's two pieces of energy. There's one little green area there over Virginia, West Virginia. There's a separate piece of energy offshore the coast of the Carolinas with more green, more precipitation. Guess what? The latest European model does not phase these two pieces, the northern stream energy and the southern stream energy, together until the system is well offshore and moving out to sea. We do have plenty of cold air in this situation. It's just the European, the last two model runs, I've been watching them closely. There's the graphic on the right that shows the European snowfall forecast, by the way. You'll notice for Hampton Roads cities, the latest forecast is showing about 1 inch of snow. And then if you move further west along Route 58, you're going back towards South Boston and further towards Emporia is when you run into maybe 2 to 3 inches of snow according to the European model. So big differences in the models, and this is going to continue between now and the event itself next Thursday, the 28th of January. Here are the GFS. On the left is GFS. On the right is Canadian snowfall forecasts. Now, the GFS model, this was from the midday run today, and I looked at the 18Z run, this evening's run as well for GFS. Really hasn't changed a whole lot in where the snow distribution is. If you look at the graphic on the left, the GFS shows Hampton Road cities about an inch of snow, possibly 2 inches towards Suffolk, and then further westward away from the effects of the marine layer in the water, you got a nice sweet spot of 10 to 15 inches of snow back towards perhaps Charlottesville, Fredericksburg, and getting up into northern Virginia. Graphic on the right, that's a Canadian model for midday. That shows about 3 to 4 inches of snow across Hampton Road cities. So, we compare the models. The track of the storm is going to be so vitally important. I can't state that enough. The positioning of the cold Arctic high over eastern Canada, funneling in that cold air, that's going to be important. So there's a lot of variables going on. These forecasts are never easy because you're involving a lot of dynamics and you're involving a lot of moving parts. And these moving parts basically have to merge or come together at the right time to get snow across Hampton Roads, especially along coastal Virginia. Back a little further to the west, away from the effects of the water, Williamsburg westward, usually you get far enough away from the effects of the water to where, you either get a mix of rain, snow, or all snow. So it's a challenge. It's never easy. All right, so we looked at the snowfall forecasts. Here is another big factor in this forecast, okay? The image on the left, I just took a snapshot of what the water temperature was this afternoon at Sewell's Point. And right now the water temperature, a few hours ago, this afternoon, the water temperature was 43.7 degrees Fahrenheit, so just under 44. If you look at the graphic on the right, or the image on the right on this slide, you'll notice a green dashed line. Now that green dashed line indicates the forecast into the future. Looks like it goes out, about 72 hours. So this goes out to the morning of Sunday the 24th. Now we have really cold air building in, cold high pressure from the Midwest building into the Mid-Atlantic this weekend. Make no mistake about it, tomorrow we're going to have some strong northerly winds, really good cold air advection, and we're looking at high temperatures, 41, 42 degrees Fahrenheit tomorrow. Then we're going to have a very cold night tomorrow night where we can see lows in the middle to upper 20s across most of the area. And then a little bit of recovery on Sunday with highs generally in the middle 40s. Could reach a little bit warmer than that. But look at the green dashed line on the image on the right, and you'll notice the forecast is for the water temperature to drop to around 40 degrees Fahrenheit by Sunday morning, the 24th of January. Why is this important? And I state this a lot. If you follow me, if you look at the blogs I put out, water temperature is one of those table setters. We have to get the water as cold as possible. The colder you get that water right offshore, the greater the probability we see frozen precipitation. Especially this time of year where we're starting to hit that peak climatological time where the water temperatures actually reaches its coldest temperatures off the coast of Virginia. Now look at this. Why is the water important? Well, winds generally spin counterclockwise, blow counterclockwise around areas of low pressure in the northern hemisphere, around storms. So, for example, this track here, we are going to be seeing a stronger north to possibly northeast wind. And the northeast wind is blowing over 40-degree water versus 46-degree water is a big difference for the coastal Virginia cities. Okay, so I'm just trying to show you why the water is so important. Because when we get these nor'easter type events with these strong areas of low pressure off the Carolinas, they generally tend to blow, the wind tends to blow around the circulation around these storms off the water, and that, whatever that water temperature is going to be very critical to the type of precipitation you get. All right, so here are my final thoughts on tonight's video. And this is going to change. What I'm saying tonight, here on the 22nd of January 2021, is going to change between now and tomorrow. It could be changed. It could be different. Between now and Sunday, it could be different. Between now and Monday or Tuesday next week, it could be different. These are some of the main points I want to make tonight. First, we're seeing a moderate chance for a significant winter storm to impact the Mid-Atlantic region and Southeast Virginia between the 27th and the 29th of January. Now, I've changed this wording to moderate chance. I initially had increasing chance or higher chance earlier today, but once I saw the midday European model run with the phasing of the northern and southern energy, the cold upper trough with that other vorticity maximum offshore and further away from the coast, I want to see the European get back on board for snow across the area before I really feel even more confident with this forecast. But right now it stands to a moderate chance because I see even this evening's GFS, the same thing as earlier. The GFS has been pretty consistent the last 4 to 5 runs with this winter storm, a major impactful storm across the Mid-Atlantic come next week. But the European has backed off on that for 2 straight runs now. The 0Z and the 12Z have backed off with the phasing further offshore. So that's something that I'm going to be paying close attention to in the next 24 to 72 hours. I think we're going to have a much better idea of what happens come Monday. And the reason I say that, let me go back. When I go to the Monday time period, let's go to Monday, right here. You see that storm system, the graphic on the left there, you see that storm system with all the rain and the mountain snows out over California on Monday? That's when the system comes on shore. And that's when we'll have better sampling of the atmosphere, the balloon launches. We're going to have much better idea once this thing comes ashore in Southern California as to its future behavior. Right now, it's well removed from the continental United States. It's over the Pacific Ocean. So these models are just that. They're models. They're simulations of what they feel is going to happen, but it's no guarantee ever. So again, look at the graphic on the left. All that rain and snow in California, back into the desert Southwest, that's our storm for Thursday. It's going to travel right across the country from Southern California to possibly Mid-Atlantic. Right? So we're going to have a much more higher confidence come Monday for sure. Now the storm track, the storm intensity, the position of the Arctic high pressure, as well as its intensity over eastern Canada are important. They're vitally important as far as, for example, a storm track. With storm track, if you get a storm that moves further south and slightly farther offshore, you're going to get more of a winter storm threat for Hampton Roads, for example. But if you get a storm that does what the GFS is showing right now, right? You get a storm like this, where it rides right along the coast. This is just too close for Hampton Roads to really get any snow. It's going to be pushed. The marine layer is going to be brought inland on strong gusty winds off the water in this case. And that's going to push your heaviest snow back in the inland sections of Virginia, and we just won't see it with this kind of track. We need a track. If you want a snowstorm, we need a track that's further southeast and further offshore. Next point, storm intensity. The stronger this thing gets, the greater the probability of colder air being dragged down and entrained within the system itself. You get that colder air and more of a northerly wind. It's going to lower the temperatures. Additionally, the Arctic high position, let's go back. Right, you see on the graphic on the left, for example, that shows a 1042 millibar high over eastern Canada. How close does that 1042 millibar high get to the Mid-Atlantic during the storm? Does it move quicker than the storm itself and move off to the east ahead of it? There's a lot of questions remaining about the strength of this high. One thing we do know is that we're not expecting this storm, unless things change drastically, We're not expecting this storm to really go all the way up the coast, up to New England like a typical nor'easter, because there's a blocking high up into Greenland, and then you got this very strong surface high. And storms take the path of least resistance. So if you have a strong high above a strong storm, strong high pressure over a strong low pressure, that low pressure system is not going to go towards the high pressure, because the high pressure system acts basically like a path of greater resistance. Here's an example for you. If you're riding your bike and you have a choice between going uphill on the bike or downhill and just coast down the hill on the bike, most people are going to pick the easier path. They're going to go downhill and just coast down the hill on the bike. They're not going to try to pedal uphill, right? Because if you pedal uphill, you're going to exert more energy. And when you exert more energy, that takes the energy away from the storm itself. For a storm system to really intensify, it's going to follow the path of least resistance towards another trough or area of low pressure. And that's going to conserve its energy towards its center or core. So hopefully that makes sense. But in general, the position of this high is vitally, vitally important, as well as the strength. The weaker the high pressure system, the less likely the air will be cold enough to bring winter weather down to Hampton Roads, for example. We need a really strong high, a 1040 millibar plus high. The stronger the better, because that's going to transport much colder air into the system. Additionally, the overall wind direction is so critical in determining precipitation type for how long it remains that way. For example, some of our biggest snowstorms in Hampton Roads in the past were all associated pretty much with a north to north-northwest wind. We need a more northerly wind component to keep that cold air coming in, and that has to do with the position of that cold high to the north that I mentioned over eastern Canada, as well as the track of the storm. So we want an overall wind direction generally between 340 and 360 degrees. And that will continue to bring colder winds. Now, or colder temperatures into the storm. Now, if we get an easterly wind or a northeasterly wind, it's going to moderate the temperatures, possibly enough to where we keep it liquid mostly. So, for example, if our water temperature drops to 40 degrees, let's say by Sunday, as I showed you here on this graphic, if it actually drops to 40 degrees Fahrenheit and we have more of a northeasterly wind or an easterly wind, that air is going to blow right over a 40-degree water temperature. Chances are your air temperature is going to be very close to that. So again, we want more of a north to north-northwest wind. Now you don't want to go back too far to the northwest, because then the air mass, the air column dries out. Okay, so that's going to be huge. And even if you get a northeast wind at the start of the storm, I've seen past winter storms where you get more of a north-northeast wind, and with time, because the track of the storm is offshore and to our southeast, with time, as that storm pulls further out to sea, the winds come around, shift around, or back to a northerly direction, and that's when the rain changes to snow. So this is very, very important. All right, expect lots of changes in the models between now and the actual event. Again, this thing's not coming ashore into Southern California until Monday, the 25th of January. Until we get it on land in the U.S., that's when we're really going to have better sampling of the environment and atmosphere to really determine the future path of the storm. So there's going to be a lot of changes in these models. I am impressed with the tendency of these models. I will say I'm very impressed by the fact that the European model hinted at something like this for late next week. This European model hinted at the possibility of a winter storm across the Mid-Atlantic on Monday, the 18th of January. And since Wednesday, the Canadian, GFS, and European have all shown the similar outcome to where we have some type of storm off the coast. So, again, that's nice. We know there's going to be a threat. We just can't pinpoint right now based on the models what you see tonight. So if you want snow and you see rain right now, don't fret. Don't worry. It's probably going to change again. Where the rain-snow line sets up, specific details about the actual snow amounts with the storm, who gets the heaviest snow, who gets just plain cold rain, where's that rain-snow mix set up, it's going to be determined especially as we get in. Greater detail will be available once we get around Monday the 25th when we get into that higher resolution model time range. Now, what do higher resolution weather models do? They are really good with detecting smaller scale changes. So some of the biggest snowstorms I've seen in Hampton Roads, there are a couple different smaller scale processes that are at work that are associated with the Western Atlantic Ocean with the water right offshore. And the global models are they're looking for the big features, right? They can't see the smaller details like the high resolution models can. So the NAM model, the HRRR, those models, as we get into Monday, are going to zone in on the Thursday time period. And we're going to get a much better feel. All right. Additionally, I want to really emphasize this. I've seen it. It's fascinating to me, really. I love to follow the weather and watch things unfold, and I try to learn from those things. The atmosphere and Mother Nature are so unpredictable. You think, you might have a good forecast, and then something happens on a smaller scale. So some of the most significant winter storms have some kind of smaller scale atmospheric process involved with them. For example, a low-level jet stream at 5,000 feet above the ground. What's known as mesoscale precipitation banding features. And this is, associated with a more enhanced area of lift. When it's a mesoscale precipitation band, it's an area where there's much faster vertical ascent or rising air motion, but it's over a small area. And I've seen some doozy storms to where the Virginia coastline and northeast North Carolina get hit really hard. I see a swath of 8 to 10 inch snow. But then if you were to get in your car and drive maybe 30, 40 miles to the northwest or just to the west of that snow band, there's nothing on the ground. It really blows my mind. I throw the December 2010 storm. This really hit me. I was driving back from the Midwest. The December 26, 2010 storm was a big storm for Hampton Roads. I mean, we're talking 12 to 15 inch snow totals. It shut things down pretty good for a bit. But I was driving back from the Midwest. I'm coming into Wakefield, around the Wakefield, Virginia area. There's nothing on the ground. It's cold. It's a cold, typical, I think it was early January when I drove through after the storm. Might have been late December. But anyway, unbelievable. I got closer to the coast, and all of a sudden there's snow everywhere on the ground, and it was deep. I measured 14 inches on my deck. So these are small-scale features. Some of the biggest storms, winter storms and accumulating snows at Hampton Roads, are usually associated with these mesoscale banding features where you get higher precipitation rates. There's almost like a feedback with the extra moisture from the ocean, from the water right offshore. It's really interesting to watch how some of these past storm events have unfolded. All right, and again, as I mentioned, it's too early to provide specific details, such as where that rain-snow line will set up, where what the snow amounts are going to be. It's just too early. Again, we'll have much better idea as we get closer to the event, particularly starting on Monday, the 25th of January. Now, being a snow lover, if you want snow in Hampton Roads, I hear you. I feel it. I feel what your pain is. It's been a while. And nothing ever comes easy for snow in Hampton Roads. The majority of storms that I've witnessed in this area, and I probably haven't lived in this area quite as long as some of you viewing this video tonight, but usually it's going to start as a cold rain. It's going to start as a cold rain. But some of the bigger storms, the more dynamic storms, the deeply intensifying storms, it tends to go over to snow. And then if you're in the sweet spot where the snow, the mesoscale bands, like I was mentioning, where that sets up, the heavier snow bands, you can get hit pretty quickly and it could come down pretty hard. Even a 6-hour window of snow at 1 inch hour, and you're looking at 6 inches total, right? So get ready. I think we have a good shot at getting a winter storm, and we haven't had much to talk about over this winter, the winter of 2020-21. It's been colder this January. Temperatures have been fairly cold, more consistently cold than past winters. We haven't seen any crazy 70-degree weather, 75-degree weather like we have in the past few winters occasionally. It's, pretty much been, seen a few days in the 50s, but has seen quite a few days also, especially in the early part of January with highs in the 40s. So, the water temperature is colder this winter. We're just going to have to see how this plays out. But I'm very interested to see how it unfolds. And let's keep our fingers crossed if you want snow. I'm not guaranteeing it in this video. I'm not hyping this storm in this video. I'm just providing my knowledge of weather with you and my experience doing weather in the Hampton Road cities, especially the coastal areas. Somebody's going to get hit, and we'll keep watching the European model trends. If that keeps the phasing offshore, and things don't really intensify till it's well offshore, there's a good possibility we might just have a dry, windy system where we don't get anything. So something to keep an eye on, and we'll be doing that here at Spot On Weather. I hope you enjoyed the video. I hope you learned something each time, and take care, everybody. This is Spot On Weather. If we're not spot on, we're not doing it right. Have a great evening, everybody. As we get closer to the event, if it still looks like we're looking at a more perilous winter storm threat, I'll be making updated videos. Okay? Everybody have a great evening. Take care. Most of all, stay healthy.